Okay, let's talk about how a guitar string actually moves. We're going to build the equation that explains it all. It all comes down to one powerful equation, and we're going to build it from the ground up. So here's the plan. We'll look at a tiny piece, check the forces, and then bring in Newton's second law. Okay, first step, let's zoom way in on a tiny piece of the string. It's almost a straight line. Now to get started, we're going to make a few simple assumptions about tension, mass, and angles. So tension is the real star of the show. It's always trying to pull that string back to straight. What actually makes the wave move up and down? It's the net vertical force from that tension. And here's a super useful math trick. For really small angles, sine is basically just the slope. So the force is really all about how the slope changes. In other words, the curve of the string. All right, time to bring in the big guns. Newton's second law. You know this one. And we're going to express this whole thing using a bit of calculus. It makes it all click. So let's put it together. We'll set our force equation equal to mass times acceleration. Okay, we do a quick bit of cleanup, and boom, we get the equation of motion for the string. And check it out. This is the wave equation. It tells us how the wave moves through space and time. But what about that v? Well, that's the wave's speed, and it's set by the string's properties. This makes total sense, right? Crank up the tension, and you get a much faster wave. And what about mass? A thicker, heavier string means, you guessed it, a slower wave. So, what's the bottom line? One equation runs the whole show, and speed is all about tension and mass. And here's the coolest part. This same equation describes light, sound, all sorts of waves in the universe.